In this video series, I work through a math problem or problems each video. When we add or subtract two rational expressions, we need to rewrite both fractions so that they both have the same denominator first before we can combine them together. Though we can use any common multiple of the denominators for this purpose, we usually prefer to use the smallest common multiple, which we call the least common denominator. To find this least common denominator, we first find the least common multiple of just the coefficients. Then for each variable, we write the largest exponent of that variable that appears in the given rational expressions. Let's take a look at the example. We need to write out the least common denominator of the two given denominators. So these two polynomials here, x cubed y plus x squared y minus 2xy, and x squared y squared plus 5xy squared plus 6y squared. We're going to assume that we have two fractions, each with one of these polynomials as the denominator. And we're going to assume that we're either going to add them or subtract them together. And if we need to do that, then we'll have to find the least common multiple of these two polynomials first. So in order to do that, let's go ahead and factor these two polynomials first. The three terms here, x cubed y, x squared y, and 2xy, have a factor of x and y in common, so let's go ahead and factor that out. And when we do, we get x squared plus x minus 2. Since the coefficient of x squared is 1, we know that we end up with x and x. 2 is a prime number, so when we factor 2, we're going to end up with 2 and 1. The minus sign in front of 2 tells me that one of these numbers should be positive and the other should be negative. And the coefficient for the linear term x is plus. So plus 1, which tells me that we need to take the bigger number and make it positive. So the polynomial x cubed y plus x squared y minus 2xy, when factored, will give us xy, x plus 2, x minus 1. Next, let's factor the second polynomial. If we look at the three terms, x squared y squared, 5xy squared, and 6y squared, I see that we should be able to factor out y squared. And when we do that, we're left with x squared plus 5x plus 6. And we can further factor this polynomial inside the parentheses. Once again, we have a coefficient of 1 for x squared, so we should start out with x and x. 6 is equal to 1 times 6 or 2 times 3. Since this 6 is positive, the factors should be positive or both negative. But if we look at the linear term, plus 5 is positive, so we need to use both positive numbers. So if we use 1 and 6, 1 plus 6 is 7, which doesn't match 5. But if we choose the other set of factors, 2 and 3, 2 plus 3 is equal to 5. So we should be able to factor the original expression x squared y squared plus 5xy squared plus 6y squared as y squared, x plus 2, x plus 3. Now that we have both of these polynomials in their factored forms, we can write the least common multiple of these two polynomials. Since the leading coefficient for both of these polynomials is 1, the least common multiple will also have a leading coefficient of 1. Next, let's look at the variables. We start with x. X appears only in the first polynomial, and it has an exponent of 1, so we'll just copy that. both of these polynomials have y and y squared, so we'll choose the expression with the bigger polynomial, which is y squared. So we'll go ahead and write y squared. If we look at x plus 2, that appears in both of the polynomials, and they both have the same exponent. So we'll just go ahead and write x plus 2, then copy what's left, x minus 1, and x plus 3. And this is the least common multiple of these two polynomials, xy squared times x plus 2 times x minus 1 times x plus 3.